Number 43, the decomposition of ethanol on an alumina surface. We studied at 600 Kelvin. Concentration versus time were collected, and a plot of A versus time resulted in a straight line. This is supposed to be a clue that it is a zero order reaction, and the slope is given. A, determine the rate law. The rate law is simply Y equals K, concentration to the N. The integrated rate law is based on the fact that it's a zero order reactant. The rate law is right there. Simply copy it down. The value of the rate constant, so that's K. See that for a zero order reactant, K is the negative slope, right? The negative slope is negative K, so K, positive K is negative slope. Positive K is negative slope. So I put a negative symbol and then just plug in the given slope. That means K is 4 times 10 to the negative 5. Next, the initial concentration was, right, so this is A naught, A with a 0. Calculate the half-life. So now I need a zero order equation that relates A naught with half-life. That's what it is. So I'll go ahead and copy that down, plug in the A naught that they gave, plug in the K, and find the half-life. Molarity over molarity will cancel. Half-life is in seconds. The last item says how much time is required for all of that initial concentration to decompose. We're looking for time, not half-life, and you can't always double half-life. Sometimes you can, sometimes you can't. So let's go through it and see if it works this time. So we use the equation for zero order. Go ahead and plug in the concentration after all has decomposed. That's going to be 0. Plug in the K. There's a negative symbol in the equation. T is what we're trying to find, and A naught is here. We go ahead and isolate the variable T. We're going to be doing some subtraction in our calculator, so make sure that you use parentheses. So we have moles per liter in the top, moles per liter in seconds in the bottom. So we'll be left with seconds as our unit. This is the time. It is double the half-life. Let's take a look back at those half-life equations and see how that makes sense. The half-life only depends on the starting concentration. If that doesn't change, then the half-life will not change for a zero order reaction. Half-life never changes for a first order reaction, right? Because K is a constant. And half-life changes in accordance with the A naught for a second order reaction. So it can change sometimes. It changes inversely here. It changes directly here. So be careful with half-life. It is not the same as T. Sometimes you can simply use it, but many of the times you cannot.